Good evening. Boyd, how are you today?
I'm all right, thank you. How are you, sir?
Okay. You didn't show up today.
I did.
Oh.
Yes, sir.
Okay. Oh, that's good. That's good.
Yeah.
Anyway, so just have to be coming around 13.
Okay. All right.
Yeah. And of course, I think even in the morning, because we only have third years and fourth years.
Oh, okay.
Meaning the class for second years will always be free.
Okay. All right. All right.
All right. So we're looking at module 16, attacking the foundation. Okay.
All right.
The module objective here is to explain how TCP/IP vulnerabilities enable network attacks. Okay. All right. So section 1 is IP PDU. This is the protocol data unit details. Okay, so we have IPv4 and IPv6. Okay. Of course, the IP has a number of characteristics, and one of them is that it is a connectionless protocol, meaning that there is no communication which has to be established before the IP, protocol has to be sent. And also, the IP, it lacks certain features. One of them is checking whether the source IP address is coming from the right source. Okay. Now, also, you find that the threat actors, they do tamper with the fields that we have in the IP header to carry out their attacks. So as an analyst, as I said, at one time when we looked at the IPv4 header, I said that you must understand the different fields in both IPv4 and IPv6 headers. Okay. When we did the lab, one of the labs on the Wireshark, you guys, you saw those fields. What did you see? You saw the version. Of course, this is the IPv4 header. Okay, so one of the version and one of the fields that it has is the version. Okay, so here, if we are going to have, I think that code has to be 100. It means that we're dealing with IPv4 packet. Then we have the internet header length. Here we have the code. Of course, we're dealing with the numbers here. So this consists of the header length, the size of this header length. And then you see we have the DS. Of course, this part here is for prioritizing the packets. Okay? So we have a situation now where traffic, which is coming from, that is video traffic, telephone traffic, needs to have a higher priority as compared to web traffic. Okay. Then here we have the total length of the packet. Identification, flag, fragment offset. So these three, they are used in a case where we have the packet moving from one network to the other network. Okay, so you find that this other network where the packet is going, it is required that this packet must have a smaller size. So these three components, once the packet has been divided into smaller parts, into smaller components, these three fields are responsible for identifying those smaller packets and reassembling them, okay? And then we have got the time to live, okay? The time to live is there so that we can't have a situation where the packet will keep on moving on the internet perpetually. So the time to live is a number. Let's say the packet can be given 64. It means that this packet has to pass through 64 routers. So when the packet moves from one router to the other router, the TTL value would decrease by 1. When this TTL value reaches 0, it means that that packet will be dropped. Okay. All right. And then here we have the protocol. What is this all about? This deals with the next level protocol. Which protocol are we going to deal with when we move from one level to the other? Of course, you saw that the TCP/IP has different levels. And then we have got the header checksum. So this is there to check for errors in the header. And then, of course, we must have the source IP address, the IP address where this information is coming from, and destination IP address where the information is going, okay? So I've just explained. Of course, have you seen here? So for the IP, of course, it's 100, as I said. So 0, 100 is the code, okay? 0, 100, all right? I've explained about all these. Now, you can see we have more details like the DSCP, okay? This is also for prioritizing. And then explicit congestion notification, this is to avoid, congestion. And very, very important that you need to take note, of anything that is in the lecture, okay? Now, the protocol, the next level after the network layer, which level is next? It is the transport layer, okay? So here you can see ICMP is represented with the code 1. If we're dealing with TCP, of course, in the transport layer, we have either TCP or UDP, okay? So TCP has code 6, UDP has code 7. As I was saying, you have to take note of these, okay? All right, so I've explained about, and then there's this other part, options and paddling, okay? So which can be used, for some certain information, okay? You see, again, there's this video which you can watch. And then this is the IPv6 header. You can see that it has lesser number of fields. So the version here is 0110. The DS was replaced with the traffic class. So this is for prioritizing the traffic. And then we have the flow label. So this is a new feature. A flow is a situation where we have traffic moving from the source going to a particular destination. So if we have got the flow label, we want a situation where the flow, that is traffic which is in the flow has to be treated in a particular way. Okay, and then we have the payload length. Next header has got to do with, it replaced the protocol. And then time to leave was replaced with hop limit. So you see, sometimes they use the word hop instead of the word router. Okay, and of course here we have the source IP and destination IP addresses. So I've talked about all that. Okay. Again, you see, we have the video. All right. Section 2 deals with IP vulnerabilities. Okay. So these are some of the common IP-related attacks that are there. Okay. So we have ICMP attacks, which works on IP vulnerabilities. So here, threat actors, of course, they're going to send the pings. So the pings, they use ICMP protocols. So they're going to send echo requests. They use pings to discover what are some of the hosts that are connected in your organization. What are some of the subnets that you have? Okay, they use this for that. Or they can use ICMP attacks to generate DDoS flood attacks. So here, a large amount of pings are going to be sent to a particular server. Okay. Or they can use the pings, to alter the host's routing table. So this is a situation whereby if the host, that is the routing table of a host, has been altered, this is a situation whereby instead of going to a particular server, you can be redirected, to another server. Because once the routing table has been altered, it means that even the default gateway can be altered. And once the default gateway has been altered, definitely you'll be redirected to a particular website. Okay. And then DOS and DDoS attacks. Okay, I did explain about these. Okay. Address spoofing attacks, whereby the threat actors can be able to falsify the source IP address. Okay. Man in the middle attack, as well as session hijacking. So here, threat actors, they need to have access to the physical network, and then they can use man in the middle attack to hijack a session, to hijack a connection. Okay. All right. So this is the ICMP attack, where the attacker is supposed to send echo requests and you'll be able to receive echo replies. Okay. Now, very, very important that in your organization, you are not supposed to allow the pings to reach your organization. Okay, so if you can try to ping certain, web addresses for certain organization, it will refuse. Why? It is because the ping is not allowed in that organization. So you have seen why the ping is not needed. Because if pings are not allowed, it means that the threat actors won't be able to know the IP addresses that you are using. Okay. So this is a list of some of the common ICMP message that are of interest to the threat actors. Okay, so we have ICMP echo request and echo replies. So these are used to perform host verification and DOS attacks. ICMP unreachable messages. This is used to perform network reconnaissance and scanning attacks. Okay, ICMP mask reply, the threat actors are able to use these type of messages to come up with a map of how the devices are connected in your organization. ICMP redirects. These are used, that is to attract a host into sending traffic through a compromised device and then creating a man-in-the-middle attack. The router discovery messages, these are used to inject fake routing entries into the routing table of a targeted host. So this is what is happening. We have these messages which are used, for a good purpose, but hackers are using it in a different way. Okay. The other attack which can be there due to IP vulnerabilities is amplification and reflection attacks. So we have the threat actor here who is going to send a number of echo requests, to a number of devices, but he is going to falsify the source address. He's going to put the victim's IP address as the source of those requests. Okay, so the requests will go, but the replies will target the what? The victim. So this is what we call amplification and reflection attack. Okay, so you can see it's saying my internet is unstable because I'm using the boardroom. I don't know what has happened to the rights in my office. So I normally use wired network, but at the moment I'm using wireless. So IP spoofing attacks, they occur when a threat actor creates packets with false source IP addresses to either hide the identity of the sender or to pose as another legitimate user. Okay, so we, of course, spoofing can also be incorporated into another type of attack called the smurfer attack. So spoofing, we have two types of attacks. We have got non-blind spoofing. So here, the threat actor can see the traffic that is being sent. And then blind, of course, the threat actor cannot see the traffic that is being sent between the host and the target. So in spoofing, we can either have IP spoofing, or MAC address spoofing attack, a situation where the threat actor here has to falsify the MAC address. Okay. TCP IP vulnerabilities. Of course, also very, very important that you know the fields that the TCP header has. Okay. So it has the source port, destination port, the sequence numbers and acknowledgement numbers. Okay. So, of course, the sequence numbers are used to know what are some of the segments which we are able to receive and which are some of the segments that we didn't receive. Okay. We also have acknowledgement numbers. Of course, with TCP, once the message has been received, then an acknowledgement has to be resent. We have the header length reserved, and then control bits. So control bits can either be urgent, meaning that the segment is urgent, or maybe it's an acknowledgement. Okay, is it a push function? Is it a reset? Is it synchronization? Is it a finished segment? And so on. Okay. Window is for windowing. So this is used to decide like how many segments we're supposed to send at a particular time. Okay. Now, if the network has been proven to be reliable, then the number of segments can be increased. So the checksum is to check for errors. And then urgent, of course, that is if we're dealing with a segment that is urgent. Okay. We looked at these properties of TCP. Okay. Reliable delivery, meaning that when we send TCP, we are supposed to receive acknowledgement. If we do not receive acknowledgements, then the message has to be resent. Okay. Because of that, TCP is used for HTTP, SSL, and TSL. FTP, when you're sending files, because when you're sending files, you have to make sure that you receive all the files. Flow control. This is a situation where we have one device bombarding another device with a large amount of information. So the receiver is not copying. Therefore, the receiver will send a message to the sender to relax. State of communication. We call this connection oriented, meaning when you're using TCP, before sending any data, a connection has to be established through what is known as a three-way handshake. And you saw what a three-way handshake is. So this is where a sender will first send a message called a SYN message. The receiver will reply with the SYNAC, and then the sender will reply with an acknowledgement. After that, that is when the two devices will start exchanging the messages. So this is a three-way handshake I've just explained. Now, you see, we have the three-way handshake. Then the threat actors are using the three-way handshake against the systems. So we have an attack called the TCP SYN flood attack. So this is a situation where hackers are going to send the SYN messages to the server. You know, the thing is, those messages, even if the sender will send the SYNAC, the hacker won't be replying. So that will leave the server in suspense, waiting. The server will be waiting for the SYNAC, but it won't come. Okay? This is what we call the TCP SYN flood attack. Okay? We have also the TCP reset attack, where if two devices are communicating, the threat actors are able to send a FIN packet. So once the FIN packet has been sent, it means that A and B will stop communicating. They have to start all over again. Okay? We also have TCP session hijacking. So this is where we have vulnerability in the TCP, and then the threat actors are able to take, they can be in charge of the communication. Okay. This is the header of the UDP, and make sure you must also be familiar with each and every field here. Okay. So UDP, of course, is connectionless. That is, no connection is established. UDP is unreliable, meaning we have no acknowledgements with UDP. Okay, so UDP is used by DNS, DHCP, TFTP, NFS, and simple network management protocol. So what are some of the attacks related to UDP? We have UDP flood attacks, okay, DDoS attacks. So these, of course, they're going to consume your network resources. And of course, the threat actors use a tool called UDP Unicorn or low-bit ion cannon to perform the UDP flood attack. So you can see that is what we call attacking the foundation or attacking what we use, okay? So this is what it is in this world. The services we are using are used against us, okay? So that is attacking the foundation. Now this is attacking what we do. So this is module 7, and the main objective here is to explain how common network applications and services are vulnerable to attacks, okay? So the first section deals with IP services. How are these IP services vulnerable to attacks, okay? ERP vulnerability, that is address resolution protocol. So I did explain about the concept behind ERP, okay? So we have these devices in a local area network. For H1 to send something to H4, H1 must know the MAC address of H4. If H1 does not know the MAC address of H4, H1 is going to send an ERP request. And this ERP request is a broadcast, meaning each and every device has to receive that message. H3 will receive the message, open it, and compare the IP address in the message with the IP address that it has. If it doesn't match, H3 is going to drop that message. H4 will receive, open the message, compare the IP address in the message with its IP address. If they do match, H4 will reply with its MAC address. So that is how H1 is going to learn the MAC address of H4. So in the beginning, H1 only knew the IP address of H4, okay? So you see, sending those broadcasts, you know, it is dangerous because if we have the threat actor connected, the threat actor can receive that information and be able to send false information to the MAC table, which the switch has. That is making his device to be the default gateway, you know. So such type of an attack is called ERP poisoning attack, where we change the entries in the ERP table, okay? All right. We also have DNS attacks, okay? We have DNS open resolver attack. So we have an open DNS service, which, you know, if you don't have the DNS server, you can use Google's DNS, okay? But of course, you find that these DNS servers are also being attacked, okay? Once you have got false information in the DNS server, then you are likely to suffer from the, you know, some redirection attacks. So DNS suffers from DNS cache poisoning attack. So this is where the cache entries, that is, the hacker is able to enter false entries in the cache, okay? We also have DNS amplification and deflection attack. So this works just like the previous amplification and deflection attack we have looked at, okay? DNS resource utilization attacks. So this is a DDoS attack which has to consume all the available resources that you have on the DNS Open Resolver. So you see, if we don't have the resources here, it means that the computers which will be coming, trying to access the services here, won't be able to do that, okay? We also have DNS stealth attacks. So of course, what the threat actors are trying to do is to hide their identity, okay? Some of these attacks that are there are fast flags. So this is a technique where threat actors use phishing and malware delivery sites, okay? And what happens here is that the DNS IP addresses which the threat actors are using keep on changing, and it will be difficult, of course, to trace them, okay? Double IP flags attack. So this is where now the host name and IP mappings also keeps on changing so that you can't trace the threat actors. And then we have domain generation algorithms, okay? So with domain generation algorithms, the threat actors take charge of the domain, and they use it to create fake domains, okay? We also have DNS domain shadowing attacks. So here, of course, the threat actors, they gather the account credentials in order to create subdomains which can be used in an attack. We also have DNS tunneling attack. So of course, it is necessary for you as an analyst to be able to detect when an attacker is using DNS tunneling attacks to steal data. So here, of course, when you see strange domain names, okay, that is a situation where they can be using DNS tunneling, to steal the information from your organization. Okay. Dynamic host configuration protocol. Okay, so we have this protocol which we use to assign the IP addresses automatically to the devices. But of course, also here we have different types of attacks, such as DHCP spoofing attack. So this is going to happen when the threat actors are going to create a fake DHCP server. So it is going to assign to your laptop the wrong default gateway. We are going to have a wrong DNS entry, and you're going to have the wrong IP address. Okay, so this creates also a man in the middle attack where you have to go through this fake DHCP server. Okay. Section 2, enterprise services. So of course, this is where we have HTTP and HTTPS. Of course, here also we have a number of attacks targeting HTTP and HTTPS. Okay. So to investigate web-based attacks, security analysts must have a good understanding of how standard web-based attacks works. This is very, very important. We have just been using other people's ideas. It is time that we have to be coming up with our own ideas. Like, for example, how do we make the laptop? How do we make the phones? We need to have our own things. That is very, very important. So make sure you must understand web-based attack, how they work. Because if you do not know how they work, how are you going to protect the organization? So this is a common stage of a typical web attack. So the victim unknowingly visits a web page that has been compromised by malware. The compromised web page redirects the user to a site containing malicious code. The user visits this site with malicious code and their computer becomes infected, of course. After identifying a vulnerable software package running on the victim's computer, the exploit kit contacts the exploit kit server to download the malicious code. After the victim's computer has been compromised, it connects to the malware server and downloads a payload. The final malware package is now running on the victim's computer. This is, what happens. Okay. All right. So server connection logs can often reveal information about the type of scan and attack. So very, very important that you analyze the logs of the server. And of course, we have different types of connection status codes that we have. So if it's 1, it means we're dealing with informational. 2, it's a successful connection. 3 is a redirection. 4, it means that the client has an error. So how does your organization protect itself against web-based attacks? Is make sure by updating the operating systems, by updating the browsers, patching them, and so on, using web proxy. So a web proxy, this is whereby, this is what we use, meaning when any device wants to go to the internet, it has to go through the web proxy. So that when we have got an attack, only the web proxy will be attacked. Make sure that you follow some of the best practices that OWASP do provide. So you can go to the internet and Google OWASP, and learn more about OWASP. So OWASP are able to list some of the common web attacks that are there and some solutions. Very, very important. Educate end users by showing them how to avoid web-based attacks. Very, very important in your organization. Okay. So what are some of the common HTTP exploits that are there? We have malicious iframe. Okay, so if you are using the iframe and you didn't do a good job, you find that attackers are able to attack these very iframes. Okay, so what are some of the steps that are there to prevent or reduce malicious iframes? Okay, the use of the web proxy. Ensure web developer not to use the iframes. Okay, you can also use a tool called the CISCO umbrella, to prevent the employees in your organization from visiting malicious websites. Okay, ensure the end user understands what an iframe is. The other attack which is there is HTTP 302 cushioning. So the threat actor, they use this response to redirect the user's web browser to a new location. Okay, so how do you prevent or reduce this kind of an attack? It is by using a web proxy. Okay, you can also be using a CISCO umbrella and also ensure that end users understand how the browser is redirected through a number of steps. Okay, domain shadowing, a situation where the domain is compromised and then the threat actors do create a number of domains. Okay, so how do we prevent or reduce such type of an attack? Secure all domain owner accounts, very, very important. There was an attack which happened in Brazil, where the hackers, took control of the domain. So you find that each and every transaction which was being done on that bank's website, it was going directly to the hackers. Okay. Use the web proxy. You can also use the CISCO umbrella. Okay. Make sure that domain owners validate their registration accounts and look for any subdomains that may not have been authorized. Okay. Email. You guys, every day in your organization, you are using emails. And hackers, they know. Okay. Examples of email threats. We can have malicious attachment to the email. So this is what we call attachment-based attacks. Okay. Email spoofing. So here, threat actors do create email messages with forged senders' addresses. Spam, these are unwanted messages. They are used for advertisements, but they can be malicious. Open Mail Relay Server. So this is the server that allows anybody on the internet to send emails. But you find that, this same server, hackers can be able to infect it. So that when you visit it, then of course, you're also going to download malware. Web exposed databases. So we're talking about some web applications. What are some of the attacks that they face? If the web application has been poorly designed, then it can face the code injection attack. Okay. So the attacker here commands the website to perform certain, activities. Okay. Of course, this is when you didn't implement what is known as input validation. So you have this web application, and it has got a form, where we have got name, surname, and so on. Let's say on the name there, if you didn't put input validation, it means that anybody can enter any character, or even a script can be entered there. Okay. Web applications also suffer from SQL injection attack. Okay. So with SQL injection attack here, the same thing. If you didn't put input validation, hackers are able to enter malicious SQL statements, which can go further and manipulate the database, and the database will be able to give out sensitive information. Okay. We also have what is known as cross-site scripting attack. So this is where web pages that are executed on the client side within their own web browser are injected with malicious scripts. Okay. So the scripts can either be, Visual Basic or JavaScript. And we have two types of cross-site scripting. There is stored. So with stored, it means that the script is going to be on the server, okay? And then we have reflected, where the script is not on the server. So how can we prevent or reduce cross-site scripting attack? Is by ensuring that web application developers are aware of some of the vulnerabilities of cross-site scripting and how to avoid them. The use of an intrusion prevention system to detect and prevent malicious scripts. Okay. You can also use the web proxy to block malicious sites, or use the CISCO umbrella okay, to prevent users from visiting malicious websites. Okay, so this is that on attacking what we do. I think you have seen, whatever services we are using, is under threat, okay, or it is used against us. Right. Okay, so I'll just introduce, I think, module 18, and then we'll continue, we'll see anyway. Understanding defense, okay? The main objective here is to explain approaches to network security defense. Which approach can you use? So the first approach is known as defense in depth, okay? But before implementing defense in depth, cybersecurity analysts must prepare for any type of an attack. Your job will be to secure the assets of the organization. Okay. Now, to do this, you must understand these terms. Assets is anything of value the organization has. Vulnerabilities, these are weaknesses in the system or its design. Threat is any potential danger to an asset. Okay. So you see, there is no way that you wake up and start protecting your organization. No. First of all, you must identify the assets that you have in your organization. Which assets must be protected the most, and so on. You can do that through what is known as assets management. This is what you use to identify the assets that, of course, you have. And of course, you also need to identify the vulnerabilities that your organization is facing. Okay. Oh, I mean, the organization has, sorry. What are some of the weaknesses your organization has? So you need to ask yourself several questions. What are some of the possible vulnerabilities that our systems are facing? Who may want to exploit these vulnerabilities? What are the consequences if the vulnerabilities have been exploited and we have lost the assets? Okay. So this is an e-banking system. Okay. And some of, the threats it faces. So we can have an internal system compromise. The attacker here uses the exposed e-banking server to break into an internal banking system. Stolen customer data. The attacker steals personal and financial data of the bank customers from the customer database. Okay. Phony transaction from an external server. Okay. Phony transaction using a stolen customer PIN or smart card. Data input errors. Okay. A user inputs incorrect data or make incorrect transaction requests. Okay. Data center destruction. A data center has been destroyed due to a natural cause and so on. Again, also, you need to identify the threats. What are some of the threats your organization is facing? Okay. Because of that, you need to implement what is known as defense in depth to protect your organization. What is defense in depth? This is where you have multiple layers of defense at the network edge, within the network, and on the end devices. So we have layered defense. Okay. So, of course, this is your organization. This is the internet. So you have the edge router. Okay. So you can implement some security on the edge router there. Then firewall. Okay. And then here we have internal router. Okay. So you can implement, that is the iOS of these routers. Maybe they can have the intrusion prevention system within them or an antivirus. And then when you come inside the organization, this is where you can have, antiviruses on the devices, host prevention system, and so on. You don't have to rely on one technique. You have to use multiple technique. So we have the onion here, which demonstrates defense in depth. So we have the first layer here of the onion. So this is the firewall, okay? Followed by what? Intrusion prevention system, followed by content filtering. Then you can also have AAA. Then you can also have hardened devices. That is, of course, you have hardened the devices by making sure that the operating system is up to date, by making sure that you have removed unnecessary services. And here is an asset. So the threat actors, first of all, they have to deal with the firewall, then the intrusion prevention system, and so on, before they reach the asset. But things have changed now. You find that we have allowed people to come with their own devices at work, to use their own devices at work, which is very, very dangerous. So now the network of the organization is represented as a security anti-choke. That is, you see, by removing a single leaf, you can find yourself, face to face with data there and then. Okay. So that is through someone's iPhone or iPad, the attackers can access sensitive data. Okay. All right. So we are going to end here today. We will continue from section 2, security policies, regulations, and standards. So far, what we have covered, do you have questions? Do you have questions on what we have covered today?
Oh.
Yes, sir.
I just wanted to find out, sir, how does a CISCO umbrella work? And my other question is, how can I avoid being redirected every time I go on the web? Because I've tried a lot of antiviruses and they don't seem to work.
Okay.
Yeah.
Just
yeah.
Okay. So how the system, how the umbrella works is that, of course, it has the database, of malicious websites. All right. Now, if we have got this traffic, which is trying to access the internet, of course, the umbrella will check for the validity of that web address, okay? If it is malicious, then the user won't go to that particular malicious websites. So that's how it works. And of course, the CISCO umbrella is connected to the CISCO Talos. That is, it is being updated. Of course, you have to subscribe for such particular services. So it is being updated with some new, information on malicious websites. Okay, so that's how it works. So traffic has to pass through it. It has to scan the traffic, okay? Get this web address, then search the database. If it is there, then the user will be denied access to that particular website. Okay. All right. Now on redirection. I mean, so you have been redirected a number of times, isn't it?
Yes. Yes.
What were you visiting?
Mostly, if I wanted to acquire maybe some downloads from certain websites. And
I've seen. Anyway, in such a particular, I haven't done much on that. I also face the same thing, especially when I'm looking for maybe some materials that I want. You find that I'll be redirected. I mean, from this particular website to another website. But what you must know is that your browser, of course, this browser here, it always, I mean, most of the time it warns us that you don't have to go to this particular website, and you don't have to do that. That's why we always say that this website, I mean, this web browser must be updated. It is for you, when you are redirected to a particular site, this website will know that this browser will know that the website that you're about to visit is not a safe website. Okay, that is a particular, I mean, that's what the only way that you can protect yourself from being redirected to a malicious website.
Okay.
Yeah. But if hello?
I just wanted to find out, like, which browser can you actually recommend to be the safest, actually?
Okay, all right. Anyway, me, sir, I recommend Firefox.
Firefox, okay.
For now, I recommend Firefox, yes. Not Google Chrome, no. Google Chrome has got issues.
Okay.
Yeah, but, sir, we can only be safe if we start making our own computers, making our own operating systems. We have to be innovative. Okay, so this CyberSec, this company which I'm running, I'm planning to be big, to be training, but not only training, but coming up with our own cybersecurity solution as Zambians. Because most of the time we've just been relying on other people's ideas. We're now going to be using our own ideas. We have everything here, but we're just exporting raw copper. It goes, we are creating employment where it goes. It comes in form of some cables, which is not good. So most of the time, you have to be self-made by understanding these things. If you are into computing, there's no way that you can be taking your laptop, to be repaired for what? So very, very important that we have to understand these things. We need to go deeper. We have to be self-made. Okay? And that requires effort from you. All right, good night. Thank you very much that you have attended. I'll see you tomorrow, same time.
Good night.
All right.